So this is, I believe, the 38th one of our monthly webinars, and it always stuns me that we've been doing it this long. Every month, I have to think about what the next topic's going to be, and we've always got more to talk about than we have time to talk about it. But this time, we're going to do, this is an opportunity for me really to find out what I think about something and to share it with you all, because this is a topic that's been percolating for me for quite a long time. And as I'll tell you in a few minutes, it came originally from my late colleague, discussion with my late colleague, Dr. Don Toasty. But this is about performance engineering and root cause analysis, which means different things to different people, I understand. But let me try to talk a little bit about what I think it means, and we'll see where we go with that. Before we get into it, as I think you all know, these webinars are eventually posted on YouTube a couple days after we do them. We record them and leave them there. And so we highly encourage you to visit that site. It's becoming more and more of a valuable resource. Performancethinking.tv is the URL you can use to get to our YouTube channel. And more people, I get emails and comments from people around the world saying, this is really helpful. And because of that, as many of you know, again, we have started developing some free webinar study guides, and our new senior associate, Ian Patterson, who I can see is here, has been starting to help us with that to get us back on track. Because what we've noticed is that we've heard from some of our colleagues that people are they're extending their study groups, or maybe even in university settings, or colleagues at ATD might have reading groups, and they're starting to use some of these webinars as discussion topics or discussion things, kind of like you'd use a book. And so we've started putting out these study guides, and you can aim your phone at that QR code and sign up for them. We're actually in the process of making them available in an easier form, where actually Ian is creating a landing page that you'll be able to essentially subscribe to. We don't have the details yet, but pretty soon we will have all those, and we're starting to add to the list. And of course, this will be recorded, and if you are watching on YouTube, we'd love it if you would subscribe and like and share and make comments on the YouTube channel. Now, we've got lots more topics coming up. This is not necessarily in the sequence that we'll be doing them, but we will be. There's a tool that came out of my work in fluency-based instruction, and actually out of the field called precision teaching that I worked in early on in my career. And it's a way to talk about pinpointing or setting objectives for instruction. And we talk about learning channels. And so at some point in the not too distant future, we're going to do a webinar on that topic, because what I've found is that a lot of my colleagues, especially in the corporate instructional design world, have not made contact with this way of getting really specific about what it is we want people to learn and what we want to teach. We're going to take another run at the sales enablement topic, which we've done a few of over the last 3 years as we've done these webinars. But we want to talk a little bit about the notion that once you define the milestones in your organization's successful sales process, that's about what salespeople would call advances. It's about the things that you accomplish or achieve in your sales process that actually represent moves forward toward closing a deal or renewal or whatever your sales happens to be. We're going to talk about upside potential and exemplary performance, also coming really out of the work of Tom Gilbert, one of our main mentors and contributors to all of this. And we often use the phrase best practices. And in fact, we've had clients come to us asking us to do best practices studies. And what they really mean is exemplary performance analysis. And I know our colleagues at Exemplary Performance, the company, Paul Elliott and Al Folsom and colleagues have written a book on this. We have a particular approach to it that's not quite exactly the same, but it's in the same direction. And it's a very interesting way to think about how do we identify our stars, the top performers, if there are such people, and leverage what we can learn with and from them. we're talking about job profiles, and I'm hoping that my colleague, our colleague Therese Longo, will join us for that, because she and her colleagues have really taken this by the horns and have been doing a lot of accomplishment-based job profiles, as well as career path models and so forth. So that's a pretty cool topic, I think, that will be useful to people. And then we're going to come back to leadership and management, which we've talked about, and there will be more. But the next one is something I've been wanting to talk about for quite a while, and it's sort of a silly topic, but anyone who knows me personally, or who's ever been in either my workspace or my home, knows that I really am a box 2 guy. I like tools and resources. I like kitchen tools. I like tools for doing stuff around the house. I love software tools. I love all of it, because I think they're enablers. And in the performance thinking approach, and in the 6 boxes model in particular, box 2 is called tools and resources, as many of you know. And I think it's a highly underutilized and highly sort of under-leveraged category of behavior influence. And so we want to dive into that a bit next time. So that'll be in February. Now, our agenda today is, I want to start out just a bit about root cause analysis. I suspect that just about everybody here knows about root cause analysis, maybe has used it in some form or other, but I want to talk a little bit about it and why people tend to do what they call root cause analysis. And then I want to give you a very brief overview about performance thinking with a focus on how it's a performance engineering methodology. And then it would control performance engineering or a design engineering approach to performance with a problem-solving approach, and talk a little bit about how that looks in our field, and maybe a little bit about how it's evolved. Then I want to focus on the 6 boxes model, the piece of our approach, performance thinking, one of the 2 models, which is probably best known, and how it really is a way to optimize return on investment if we look at the whole system. I want to talk about ways that we have combined root cause analysis with performance engineering, because those things don't always go together. And I want to sort of give you kind of a thought process that we use when we think about that, and then give you a couple of examples from work that we've coached and addressed recently, and then there's some takeaways. And we often don't have time to have a lot of discussion. I sure would love to have some back and forth after this in the chat box. And by the way, if you have questions or comments now as you listen, please put them in the chat box. I probably will not respond in real time unless they're kind of really important ones to respond. But what I can see now is yeah, there we go. Anyway, I'm seeing another group of people, including Therese, masquerading as Don. So let's go for it. So this man, Dr. Don Tosti, was a colleague and friend of mine for many years in the International Society for Performance Improvement. And he was an important contributor in that field, starting out as an applied behavior scientist, really doing instructional design work and instructional work like many of our colleagues who were thought leaders in the early days of performance improvement. He had a job, he did a bunch of work in Job Corps, he designed a lot of programs, but then he shifted really, as did many of those early thought leaders, into performance improvement. He did important work on organizational culture that informed some of my work. And he was a friend over the years. And we had a discussion back in, I think, the 90s, might have been a little bit later than that, but about the history of performance improvement. And what Don told me, and this is really the inspiration for this session and the thought process that I'm going to try to unpack, what he told me was that in the early days of human performance technology or performance improvement, the founders, the early thought leaders, including himself and Tom Gilbert and Gary Rumler and Dale Brethauer and others, were essentially instructional design people who started out as behavior scientists, applied behavior scientists, and they were doing instructional systems design. And what they were trying to do, of course, was optimize learning. They wanted to get the most learning from learners, the most time effectively and cost effectively as they could. And so they were looking at overall performance system or overall instructional systems and how those all work together to accelerate learning. And what he said was that the early performance improvement folks, and if you look at, again, Breathauer, Rumler, Gilbert, et al., what you see is the early performance improvement people were looking at performance systems. They were saying, how do we optimize all the conditions for an individual, for a team, for a process, for an organization, at whatever level we're looking at it, to sort of get the greatest return on investment that we can? How do we optimize it? How do we make it work as well as we can? But what he said is when the process improvement and quality movements kicked in pretty aggressively, and I would say that's probably sort of 70s, 80s timeframe, that people started focusing on how do we fix the defects or errors that come out of our processes. And so that shifted, again, according to Don, that shifted the focus among many people in the broader field or discipline of performance improvement toward problem solving. And so they began to focus and think of performance improvement as a problem-solving discipline. And what Don told me, and this is what I want to unpack today, is that, and as soon as you think about it, you realize this is true, that when you become a problem solver and you look at a problem or a defect or an error that you're trying to fix, you risk not looking at the whole system. You risk just putting your finger in the hole in the dike and fixing that rather than building a better dike, to use a metaphor. So that's what I want to sort of talk about today, because Don got me thinking about this 25 years ago. We even did a joint presentation at ISPI once about it, and it's been bubbling up for me for a long time, and I wanted to share it with you all. So as I mentioned, this work originally came from instructional systems design, called different things, but it was about optimizing instruction. And that's really where I came from. I started out as a laboratory scientist working with B. Barrett and humans. But very quickly, I became an early contributor to the field of precision teaching, which was about essentially applying Skinner's experimental analysis of behavior with learners one-to-one in a classroom. And as that expanded, both in education and then in the early 80s when I got into corporate training and development, we were not really focused on fixing problems. This list is just a few examples of the kinds of things that I and my colleagues have worked on over the years. We wanted to get customer service representatives up to benchmark productivity as quickly as we can. We weren't trying to solve a problem, we were just trying to optimize the system. Or we wanted to get customer satisfaction as good as it can be, or we wanted to identify what the best practices sales process was for any given organization and be sure it gets implemented with high fidelity. Or we were trying to create a process and a program in various parts of the organization to support competitive advantage. Or, for example, one project I remember for sure, which was enable the marketing programs created by marketing departments to really be fully implemented by the sales force. Finding ways to optimize factory maintenance and reduce mean time between failure. Help be employer of choice, etc. Now, these could be framed as problems to be solved, but basically they were not. We came in with a perspective that we can improve this, we can make this better, and we can set the stage for continuous improvement. And that, I think, is what Don was talking about when he talked about design engineering approach to performance. We're trying to optimize the system. And we really weren't problem solvers. We didn't think of it that way. Now, if you look up or know about root cause analysis, you recognize that there's lots of definitions, but a root cause, according to the American Society for Quality, which is a pretty good resource for this topic, a root cause is defined as a factor that caused a nonconformance or error or defect and should be permanently eliminated through process improvement. The root cause is the core issue, the highest level cause that sets in motion the entire cause and effect reaction that ultimately led to the problems or the defects or the errors. And so root cause analysis is an approach used to uncover those causes so they can devise solutions. So that's a pretty good standard kind of description of what root cause analysis is. Now, there's a tool that many of you may be familiar with, and I I always get a kick out of it because of its two names, the Ishikawa or fishbone diagram. And it's fundamentally a problem-solving tool. And this is an example of a template where what you're trying to do is the labels that are not here. This is just a template. It doesn't have specifics in it, but there are various types of causes about materials, about people, about various things. And we're trying to identify all of them and see how they contributed to the error or the problem. That was the focus of typically, and is the focus of root cause analysis and problem solving. And this is a convenient way graphically of sort of capturing information designed to try to identify the root cause. Now, if we're talking about human performance, if we're not just, for example, finding the root cause of, an exploded machine or something like that, but if we're explicitly tracing this to human performance, root causes are the factors that contribute to human error. They're what we would call behavior influences. They're the things that either are root causes of the good stuff, or are usually thought about as root causes of the problems. And a lot of times, as I've worked with process people over the years, there's what I perhaps slightly cynically refer to as the human error bucket, where people say, oh, well, that's just a human error thing. And this happened to be cited on a LinkedIn page, and I just pulled it off as an example. But this fellow said, this got me thinking about the phrase, the incident was caused by human error. You hear this line quite often in the cybersecurity world. And as professionals in the tech industry, we need to reevaluate the assessment of human error. Now, notice the statement. It is as though the human error was the root cause, the cause. But the question we might ask is, well, why did the human error happen? And so just sort of tossing people in the human error bucket, tossing, problems in the human error bucket doesn't really get us very far. But we, in the performance improvement world, have a model for that. We have the 6 boxes model. And as most of you know, that's our plain English sort of evolution from Tom Gilbert's behavior engineering model. It traces its history, as you may or may not know, but you can certainly learn about it on our YouTube channel, back to B.F. Skinner's natural science. And it expanded the categories of the variables that we look at because we humans vary from one to another and we work in different environments. And so what I would argue, and I think we've seen over the years, is that there's really nothing that can affect human performance or human behavior that can't be encompassed by in one of these cells or multiple cells or a systemic set of these things all connected with and aligned with one another. Now, I always like to show this, even though it's really not that big a deal, but it's still fun to show. A couple of years ago, one of my colleagues had a session, which I didn't know was going to happen at the International Society for Performance Improvement Conference. And they voted on the best performance model in the world. And guess what came up best? 6 boxes model. And the reason I like this is because I think the reason people like it, beside the fact that I've been talking about the 6 boxes model since about 1988 or something like that, so it's been out there for a while, is the plain Englishness of it. It's the straightforwardness of it and so forth. Anyway, within that model, and those of you who are performance thinking or 6 boxes practitioners know this job aid, we can define the entire system of the things that that go to support or get in the way. We can talk about the thing that what works. And if you look at this slide, what this is probably one of our oldest job aids, but it identifies pretty well pretty much everything that ought to be in place to support successful behavior to produce whatever it is we're looking for. And also what can go wrong. So we can also identify the things that aren't working, like expectations and feedback are not aligned with consequences. We tell you to do this and then you get paid off for something else, or, inefficient or poorly designed job aids. Sometimes bad documentation can really mess up performance, or people are not fluent in key skills and knowledge, which means they hesitate, they might make mistakes and so forth. So this is kind of your framework, if you will, even for root cause analysis, if you were trying to understand why there were problems. So the 6 boxes model works very well as a performance engineering tool and potentially as a root cause analysis framework. And we have colleagues, quite a few of them, probably many that I don't know, who've taken the Ishikawa or the fishbone diagram, and they've made the the bones into the 6 boxes. So you can see expectations and feedback, tools and resources, consequences and incentives, skills and knowledge, selection, assignment, motives and preferences. Those are the categories of the cells of the 6 boxes model. And some people, when they're doing root cause analysis, they literally use fishbone diagrams and start listing the things in the categories that may be causes of a defect or problem. And that's all good. That's a good thing. I'm always happy to see when people do that. But, and this is the point I'd like to sort of dig into a little bit, if we focus on just addressing the root causes of problems, so we're going to fix that problem, we may have what I could call point solutions that don't look at the overall system. So we say, oh, well, no wonder there's a bad job aid, so we'll fix it. Yeah, but what about all the other stuff? Is it all working perfectly? Maybe not. We don't know. And if our focus is on the problem and the root cause of it, we may very well not, we may miss opportunities to optimize things. And so, yes, we can identify behavior influences in a root cause analysis that account for performance problems, and we may find big issues that we can fix, and that's a good thing. But as I say, a more systemic view, a design engineering approach or a performance engineering approach may lead to a broader, more systemic optimization. And so the silly metaphor I think I've already used or analogy is, it's like plugging a hole in the dike rather than making a better dike. And if you think about a lot of the environments that you might work in, there's a lot of situations where that's the case. We say, well, we're going to have performance pay, a consequence. Yeah, but what about the fact that the documentation isn't very good? Or what about the fact that people don't get a chance to practice until they're fluent? What about those things? Performance pay is not going to lift everything up. It's going to be one component. And so if we can look at the whole system, we have a better shot at optimizing things. Now, if you think about errors and defects in a process or any other, but usually it's a process, those really show up in accomplishments, in outputs, in what people contribute to their organizations. So the reason we don't like errors and defects is because they undermine the valuable contributions that people are trying to contribute to their organization, either as individuals or teams or processes. And of course, Tom Gilbert, most of you know Tom, or knew Tom, or know his work. He made this really explicit. And, we've founded so much of our work on this phrase, this paragraph, these 2 paragraphs almost, which is the focus on accomplishments. As you, I'm sure, have seen me quote and probably know in that famous book, Human Competence, that he published in '78, he said, in the great cult of behavior, and he means everybody basically that is looking at behavior, behavior itself is viewed as an end rather than as a means to an end. But we must enable people to produce accomplishments, the valuable products of behavior. So if you think about a defect, it's typically a bad decision or a faulty widget or a car that doesn't have things fitting together properly. It's a thing, it's an accomplishment that is not meeting, the criteria it needs to be considered okay. And we call them work outputs. Most of you know this. We coined that phrase because what we observed in the field of performance improvement is a lot of variation in how people use the word accomplishments. It's a great word. It sounds valuable. It's important. But if you look in the literature, there's an awful lot of people who use verbs to describe accomplishments. Well, verbs are action. And we want to be very clear that what we're talking about is the valuable products of action or behavior. And so those might be tangible things like widgets, that can be defective. But they all made also things like decisions or relationships or transactions, which are a little bit less tangible. So we're anchored in accomplishments. And actually, I think I saw Matt Linder here, who used to work with the person where this came up some years ago. I was talking to the CEO of one of the larger behavioral health organizations. And he said to me, well, can you tell me again what's so important about this accomplishments thing? And I said, well, have you ever been in a meeting that failed to produce any valuable accomplishments? And, the light goes on at that moment. He said, oh, yeah, no kidding. We didn't produce anything valuable. We just behaved a lot. Now, Gilbert had this wonderful formula that if you want to, you can use in a sort of a quantitative spreadsheety way. But I tend to think of it more as a conceptual way to think about what we're trying to do here. where he said the worth of any given intervention to help improve performance, the worth is equal to the value of the accomplishments that it increases or enables people to produce, divided by the cost of behavior. So, for example, if we have a training program that's expensive to design and to develop, that requires people to go off the job, that teaches them a bunch of stuff, but it doesn't enable them to improve the number or the quality of their accomplishments, we might question, is it justified, does this justify the cost? And in current day nomenclature, of course, that would be return on investment. So I like to think about our jobs as performance improvement professionals as people looking to optimize return on the investment in what we do to help people perform better. And so that kind of sums it up. We want to maximize return on investment. Now, I want to talk a little bit about performance thinking from that perspective, because as you all know, it's a plain English approach, and we explicitly think of it as a design engineering or performance engineering methodology. And again, you know that we have this performance chain model, or most of you probably know this. And in the performance chain, we define what we think of as the elements of performance. We start with the end in mind. We want to know what's at stake for the business or the organization or the society. And then we look at whatever the performance is, whether it's in a process or if an individual or what have you, and we say, what are the accomplishments? What are the work outputs here? And those are a bunch of different words that prompt us to think about accomplishments. And once we know what those things are, we then say, okay, what's the behavior needed to produce those? And we look for best practices or exemplary behavior. We may do task analysis, we may observe superstars if there are any, but we're trying to capture specifically the behavior to produce the outputs. And then we figure out what the behavior influences are. And so, emphasizing that work outputs are things. So it's a big deal. So this is how we think about performance, and we focus on outputs. And of course, if there are errors or mistakes or defects, those are going to produce less than the ideal number or quality of work outputs. That's where it'll show up usually. Now, in a simple process, we would typically not only look at the final product. In this simple case, these three players, the author, the approver, and the editor, are ultimately trying to produce a content specification document that's approved. But all the other circled things are intermediate outputs, and any of those can go wrong. And in fact, sometimes in processes, we say, oh, no wonder this isn't working, because halfway through the process, there was a bad decision, or some document wasn't completed, or whatever. So we look for defects and errors, sometimes inside of processes, but it's usually focused on the work outputs. Again, you may already know this, but we use the 6 boxes model then to make sense out of behavior influences, to organize it in a systemic way. And one of the things I would highlight here, at least this is my perspective on it, is because this model evolved from Skinner's behavior science, which really accounts for behavior and is a natural science devoted to, as he would have said, the prediction and control of behavior or influence of behavior. And because it also takes into account individual variation in humans, it is a complete model. Those are not arbitrary categories. They all line up, and you can look at our webinars that are more focused on the 6 boxes model and learn more about this if you like. But this is a complete model. This is all the stuff that influences behavior that sorts into this model. It's not, some of the things you see out there as performance improvement models have these categories that really don't line up. They're just piles with names on them. But this is a set of functional categories that all work together. And the way we apply them with these 2 models is we figure out what's at stake for the organization. We then identify the work outputs that contribute to those results, or that define the hunk of performance, the process, the job, whatever we're looking at. We then say, okay, what's the behavior? We do task analysis, we do interviews, we observe people. What's the behavior needed for producing them? How are we going to measure it? Can we measure business results? That's kind of a lagging indicator, but it's important to have. Can we measure behavior? That's costly, but it's often useful for feedback and diagnosis. We can account good outputs and defective ones. That's often what you see in process improvement work. In any case, we want to figure out what we might measure. And once we do that, we then look at the behavior influences and we say, let's analyze. Let's look at what's working in each of the cells of the box and not working. of the boxes, to support the behavior, get in the way of the behavior. Let's brainstorm how we could improve that. Let's do some ideation, as design thinkers do. And then let's choose the best combination of behavior influences that we think is likely to support the desired performance. Once we do that, we implement and we measure, and almost guaranteed we continue to adjust and refine, which is kind of the agile part of all this. And then, of course, we have this other thing that we talk about, because our model is powerful, because our models are powerful because they're plain English and we can share them with our stakeholders. We're not talking like geeky nerds about performance. We're using language which people don't even think of as a technical language in many cases. So this is how we do performance engineering. And hopefully you can see that if you go through a process or a logic like this, you will optimize a system, because you're going to analyze what's working and what's not across the cells of the model. You're going to brainstorm how to improve those things, and you're going to try to configure the most cost-effective combination that you can, a system, in other words. Now, if we compare that, a sort of performance engineering approach, with a more of a problem-solving approach, there's a bunch of ways we can think about it. So first of all, what's the purpose? Performance engineering, as I've already said, is about optimizing the performance system for maximum impact and ROI. We don't want to spend any more money, time, or resources than needed. We want to minimize waste. We want to optimize production of outputs. We want to keep our people engaged and happy. We want to optimize the system. In a performance problem-solving approach, we may simply want to repair whatever the root causes are that resulted in the problems or defects or errors. We want to fix those things we identified that are really a problem. Now, where it typically starts, if you think about performance engineering, I already took you through that logic, but we identify the work outputs of the desired performance, the criteria for what good ones would be, and the behavior you need to produce. In other words, we figure out what this system is, what are the elements of it, and that's where we begin in performance engineering or performance thinking. Whereas in performance problem solving, there's more of a inclination to start with root cause analysis, where we identify the problems and the behavior that produces them. So we zero in on the things that are causing trouble. And then in our analysis, of course, again, in performance engineering, we look at both the positive and negative behavior influences that are influencing the behavior. We use the 6 boxes as a completeness framework. Whereas in a problem-solving approach, we may use the root cause analysis mostly to identify the causes of the behavior that needs to change to eliminate the big trouble, the problems. And then, again, in a performance engineering approach, which is, I like the phrase design engineering, which is a phrase that Don Tosti introduced to me, because we really are designing a system. And in that context, we, as I've already said, we brainstorm possible improvements in all the categories of behavior influence, and we then choose them ideally to optimize performance. Whereas, again, we may or may not, but in a typical problem-solving approach, we're trying to just fix the root causes to eliminate what we identified as the problems. We're not necessarily looking at other opportunities to improve or align behavior influences. And the resulting intervention for a performance engineering approach is our best guess, at least our best shot at the factors in all the cells to optimize our return on investment and to keep people positive and aligned and have it all work together. We risk, with a problem-solving focus, that we've identified a few factors that may be in one or maybe in multiple boxes in the 6 boxes model, but it's not necessarily systemic, to eliminate those errors. So that's kind of the way I think about the comparison now. I admit that this is a bit of a straw person, straw man, whatever, because maybe not everybody does problem solving that way. But if you're focused on the problem, you may miss the whole system, which is the point that I'm trying to make here. Now, and as such, we risk creating suboptimal point solutions that don't really optimize the thing. And we might have to come back and fix other stuff. Now, what we think is that a better alternative, and I've sort of said this in about 7 different ways already, I think, but we think we should design interventions that look at the whole system, and the 6 boxes model is a really convenient way to do that. And this is a graphic that's I often have used in an animated way to make a variety of points, but it's not animated here. But if you check this out, you will see that every single one of the cells in the 6 boxes model has a potential functional link with the others. So for example, expectations and feedback If consequences are not aligned with that, we got a problem. Or if we set expectations and provide lots of feedback, we can probably get a development of skills and talent. Similarly, if we're developing skills, we should be setting clear expectations about how they apply in the job. Or if we're selecting and assigning people, box 5, in other words, if we're hiring new people, we ought to be clear that the expectations for that job are clear, which is not often that's not the case. So you can think through with the connections between all these cells, what all those links are. So this is not 6 lists of behavior influences that we can pick from. This is a system where if you change one bit, it may change the other. It may change the impact of the other. You want to be sure that it's aligned with the other. So for example, if you have a tool in the form of a job aid, a really good, useful job aid, that's not only a tool that you use while you're performing, but it also is a tool that hopefully sets expectations. And if you use it frequently, it might enable you to develop skills. So you got a 2-fer there. You got a thing, or 3-fer. You got a thing which is a useful tool for the performer if it's been user tested and actually works. You got a thing which sets expectations about what to do and ideally what to produce. And you got a way to develop skills without maybe taking people away from the training. So those are examples. We want to optimize this. We don't want to just fix a bit of it. And of course, the classic thing, without even thinking about it this way, that so many of our clients and stakeholders do is they say, oh, we got a performance problem. We better train them. We go to box 4, skills and knowledge, which can be a very expensive intervention. And if the other 5 cells are not well aligned with that, it can be way expensive and the ROI can be pretty bad. So here's how we think about possibly combining it. And part of what's brought me to this webinar, actually, or wanting to do it now, is, as I mentioned, I've never had projects or clients who came to me and they said they wanted to solve a problem. And I think it's because the methodologies and tools that I've had over my career, fluency-based instruction, performance thinking, et cetera, have all been, in one way or the other, designed to improve stuff, to make things better, more efficient, more effective. They haven't been really focused on problem solving. But I have recently, in working with one very large company, been encountering more examples where the presenting thing was a problem, a gap, an issue that needed to be addressed. And for years, I've watched my colleagues who do behavioral safety work, and seeing that they're entirely focused on behavior and often can't necessarily or don't necessarily identify the outputs or accomplishments. And so it's gotten me thinking a lot about how and when we might combine these things. And I want to give you a few examples after I kind of go through this logic. And I just created these steps recently to make what I think explicit. So I'll be interested to see what you think. But first thing is if we're doing, if we're really doing performance engineering, we want to set as our goal, we want to optimize this thing, whatever it is, this process, this job role, et cetera, et cetera. And we don't want to just fix it. We don't want to just repair the problem. We want to optimize the system. And so if there is a problem, if there's a presenting problem, this is where root cause analysis has come in, because we might want to say, well, let's take a look. There's some defects here. Let's, for the moment, zero in on those, the behavior that produces those errors, and let's try to at least figure out what's not working. Is it bad documentation? Is it conflicting expectations from management? Is it, lousy tools? What is it, So we may well zero in on those problems doing a root cause analysis. And this is where I think it's helpful, because it can help us say, wait a minute, let's start here. Let's look at this more carefully. And then, again, if you use the 6 boxes model for that, that's a way to do, you can, if you want, you can do your fishbone diagrams where the bones are the 6 boxes. But we want to shift to outputs and accomplishments, which is probably where the errors arose anyway. So we want to be sure we're really crisp about what a good output is at any place in that process of the system, so that we really know, which ones are problematic. And this will be part of the identification of root causes. But then I think we can go beyond that. Instead of just fixing it, we can do things like look for exemplary behavior. We can say, wait a minute, what's the best practice behavior in the organization or any place for producing these outputs to spec. And that's different from just changing the root causes. That's like, let's raise the bar a little bit. Let's find out how the best people do it, if there are any people who are really stars. And then we can go through the ABC process that we talk about for those work outputs and possibly all the rest of them in the process. We can analyze what's working and what's not. It isn't just the big, scary problems and root causes, but it's let's look at how all the 6 boxes work together here, analyze what's positive and negative in each cell, brainstorm ways to improve them, even if it's not the worst possible problem in the world. Could we make the documentation better? Would that make training less expensive? Would that possibly set clearer expectations? Can we build a little bit of feedback in that also has some enthusiasm about it so it functions as a consequence, etc.? So we look at the whole thing and we start thinking about it as an optimization thing, not just a problem-solving thing. And then basically adjust that so that we optimize the whole system. So I think what I'm saying is that root cause analysis as a thing can help us zero in on where the big holes are. But if we then stand back and say, let's look at the context of this, let's look at the outputs around that defect or that come before it, let's be sure we got them right. And then let's look at the behavior for producing those, and let's see if we can optimize this whole system. So that instead of, for example, depending on just fixing one part of it to do the heavy lifting, we can optimize it based on the relationships between the cells. So that's kind of my process for thinking about this. And I think we'll have a few minutes when I finish here, and I hope people might have some suggestions. So here's one example. Recently, I've been coaching through our practitioner program a project that was about delivery truck drivers and the effort to basically optimize their performance by reducing accidents. It's not like their accidents are a horrible mess right now, but how can we make it so that our drivers have accident-free, driving, so they don't back into people, that are behind the truck, or they don't get distracted by a dog that runs in front of the car, or whatever it is. They don't travel too close. They don't to the vehicle in front of them, so that if the vehicle stops unexpectedly, they run into them. And so what we realize there is, even though we probably can optimize this, we can probably look at not just the big trouble, but we can identify the behavior. And the idea is that companies that do this kind of work, that deliver zillions of things to people, typically when there are accidents, they do an analysis which amounts to a root cause analysis. So let's take a look at the root causes of those accidents, and maybe let's see where the root causes that really cause the most trouble, and let's at least circle those ones and be sure we've handled them. But let's also look at the whole system, because it may be that by fixing just those things that seem to cause the problems, that might have impact on some of the other behavior influences. And so let's step back and look at the whole system, not just fixing the root cause. And so that's the ideal of optimizing sort of the driving safety rather than necessarily really fixing a big problem. Another one that came up recently was some virtual training programs that used to be in person before COVID. And what people found, there was a problem here from one perspective, which is in the current virtual version of those programs, there's not quite the same level of participation and engagement as there used to be. So how can we take a look at this and optimize participation? Now, there may be one or two factors, like, for example, when people had to go away to a hotel or whatever to get training and leave behind their jobs, they had to be sure there was coverage so they could afford to leave their jobs. But it's possible. And so you could say, well, we just want to be sure they have coverage. And so then they can engage in virtual training, even if they're in the next room from their usual office. But again, that's kind of a point solution. Let's look at the whole thing and see if we can not just fix those things which changed because they've gone virtual, but let's optimize the whole system, and let's see if we can take a look at what's different between the in-person situation and the behavior influences that support engagement and the virtual situation. And let's see if we can optimize the conditions in the virtual situation to produce the same level or even better engagement. So it's a blend, but it's presented as more, let's optimize the ROI and engagement of this thing. And then a third one is quite a few years ago, but we've seen a lot of examples of this, where people where an organization, big organization, had, again, it's kind of a problem. You could say it's a problem because there was turnover in this organization, like there are in most, and they were trying to figure that out. And they were trying to do a sort of a top-down approach, which was, well, if we just pay them more or whatever, some point solution. And so my recommendation there was, let's analyze, in terms of the outputs or accomplishments, the outputs of these frontline workers, and then let's talk with them about the behavior and the behavior influences for supporting their jobs, and look for opportunities to improve and align and make positive all of the behavior influences. So let's be sure there are no competing expectations. Let's be sure that the tools really work well, are not a pain to use. Let's be sure that there's some recognition for doing good work, not just punishment for not doing, for making mistakes. Let's look at the whole system, because if there's one thing we know about employee engagement, I want to have a place that I like to work and that I can be productive. And so this is a systemic thing. It's not just a fix one point. Now, these are examples that I think you would probably agree kind of blend across problem solving and optimization. But if we just left them in a problem solving mode, at least my perspective is, we wouldn't optimize the system. So here's some takeaways, or some suggested ones. First of all, root cause analysis is a problem solving tool for identifying cause of errors or defects so we can eliminate them. Everybody kind of knows that. And there's various ways of doing that. We think the 6 boxes model with maybe fishbone diagrams or other things are a pretty good way to approach that. But when we focus on just solving problems, we risk creating point solutions that don't optimize the overall system. And that's really, I think, the main point that Don Toasty communicated to me. And it seems a little intellectual maybe, but if you start looking at how people do stuff, you realize it's a real thing. Now, an engineering approach, a design engineering or performance engineering approach, looks at the whole system and says, we want to optimize this thing and be sure we know how all the pieces fit together so we can get the most improvement or the most production of accomplishments or work outputs with the least investment of time, energy, money, blah, blah, blah. Let's be sure these all are positive and aligned. And the 6 boxes model not only gives us a framework for root cause analysis, but also for a whole system approach. And we think that performance thinking with the 6 boxes model, because it's plain English in part, but it is very definitely aimed at optimizing performance and ROI, not just fixing problems, even though it can be used that way. So let me just go through a couple more slides here, just sort of the shameless commerce part. We have, as many of you know, some of you have been through, every few months, about 3 times a year typically, we do an open version of our performance thinking practitioner program, which is a performance consulting certification program, basically. And by now we've had, quite a lot of people, quite a few hundreds of people who've gone through that and been certified. Our next one starts April 1st. It's getting pretty full, actually. So we would encourage you or your colleagues or anybody who's interested, or tell your friends to get in touch with us sooner rather than later, because it is filling up, and it's a great way to sort of start out the first half of your year. And if you point your phone at that QR code, or if you go to performancething.com and then look on the front page where this thing says Open Virtual Program, you can get all the details about it. We also, and we are saying this a lot, they're not ready yet, but we're kind of excited. One of the things we've been trying to do is figure out how we can make the work that we've been doing for like 30 years on this performance thinking thing more accessible to people who might be interested but may not have budget to sort of sign up themselves to be practitioners, or to bring us in to develop a whole team, which is a budget item and takes a while to get approved and so forth. We are planning to have a series of inexpensive, well under $100 a piece, application kits that individuals can purchase, and whole teams can purchase, each person gets one if they want, that will actually be templates and steps through those templates with some instructional videos and so forth for how to do a set of things. And this actually came out a lot of doing these webinars, because we realized over the last 3 years, as we've pinpointed things, there's a whole lot of specific applications that you can learn where you don't have to know the whole methodology or be certified. So if you want to get on the mailing list for that, and also for our study guides, point your phone at that QR code. These are the study guides, and so you can also subscribe to them. And as I said, my colleague Ian is working on to make these a little bit more easy to access. So that's what I have to say today. This is useful information, we hope. What I'm hoping is that maybe some of you might have some comments. So I'm looking in the chat box, and I have some nice positive comments. Go Bucks too. There you go, man. And I wonder if anybody has any thoughts about this, because I know some of the folks here, I'm just looking at the list of participants as I look down it. I know some of you have been involved for sure in problem solving, root cause analysis kind of stuff. So what do you think? Any comments or questions about this? Well, thank you, Jessica. What do you think? Any comments about it or insights that you might have come up with, changes in mind? And Mickey, how might you help a stakeholder insist they know what they want to do? Well, that's a good question. That topic, Mickey, is an important one. It's a lot of what we actually talk about in our performance thinking practitioner program, because as you know, a performance consultant, whatever department you belong in, whether you're a process person or learning and performance or whatever, you can't do it all. The people who control the top row of that 6 boxes model are generally the leaders, managers, and supervisors. They set the expectations, provide the feedback, and so forth. So there's a couple of ways to approach this. And what we say is that you need to learn how to partner with your stakeholders. And sometimes you'll go to them and you'll say, there's a bunch of stuff here that ought to get done. And they'll say, thank you very much, but we will handle that. You just do this part. Just give us training or whatever. What I often would say in that context is, if you want the greatest return on investment for this thing you've asked us to do, which often is training, as you probably know, we need to work with the managers and supervisors and leaders in your part of the organization to be sure they set expectations that, people use what they learned in this training program, that give them feedback that they're doing it appropriately, give them recognition when you say, wow, that's fantastic. You've done this based on that training program you went through. So a lot of it really is about, and to be honest, one of the things I do when I have a new client, especially, is I will take those 2 models, the performance chain and the 6 boxes model, and I'll either online or if I can be in their office on a whiteboard or a piece of paper say, well, let me show you how we think about this. We want to know what's at stake for the organization. And then we want to know what the valuable outputs are that we're looking at. And sometimes that's the secret, because a lot of times people want to just intervene in some skills and knowledge or competencies ways, but it's not clear what the outputs are that will help improve. So we want to get clear about that at least. And then let's look at the behavior. And then let's look at the behavior influences. And then I'll show them the 6 boxes and I'll point out how they all line up together. Now, that doesn't guarantee that you're going to change that stakeholder's mind who insists they know what they want to do. But if you expose them to that way of thinking, they might come back in a few months and say, hey, that some of that stuff you identified here might be worth talking about. Come on back. So that's at least my short response to that. I'm looking at, positioning the troubleshooter to focus on what's real. Yeah, absolutely, Don, or actually I think it's Therese. If the process for doing X is complex, many organizations do a process analysis and then set up multiple 6 Sigma teams to optimize that process. What I found, or when I used to be very intimidated by 6 Sigma and Lean folks. And then I had the opportunity to work with some really sophisticated ones. I was intimidated because they got so much data often, a lot of tools, and I was like, whoa, But what I learned with, for example, at one of the big biotech companies, global company, working with some real hotshot process and improvement people, is that we could collaborate very well. And what they told me was, on one big hairy process that we worked on, was that two things that we offered made a difference. One was focusing on the outputs or accomplishments at each step in the process rather than just the final one, because process people don't always do that. They do process mapping, with steps, behavior, but they don't always say what the successful output of each step is. And that was the first thing. We insist on that, and what a good one is. And then the 6 boxes model as a framework for dealing with that human error bucket. It's like, oh, this is a framework. So what I found is that we could work together with them in a collaborative way where they said, oh, this is valuable. And of course, what they do is powerful in many cases, but the collaboration helps a lot. So Scott says, it seems like it'd be harder to put a dollar value on optimal rather than resolving a problem. That's true. There's different ways of going about that. One of them is sometimes I think you can point to past projects and experiences where you say, look what they did there. They just fixed part of it and then it blew up in another 2 months or whatever. Sometimes there's this history you can point people to as examples. But another way to think about it also is, if there's the opportunity to look at exemplary performance, if any team or any assembly line or any part of the business has some stars, either individuals or teams that are performing super well, then, as you know, Scott, one of the ways Tom Gilbert would talk about that is potential for improvement, or we talk about upside potential. And you could say, well, I think we can do better than that. And a lot of times, in my experience, if you just talk about what you discovered in a 6 boxes analysis, people say, oh, you're right, we could fix this. So, and a lot of times those way to fix it, the classic one, as you all know, is sometimes job aids with some feedback are cheaper than training taken away from the job. So a lot of times if you have a discussion with your stakeholders and you look at all the things you could do, you can actually minimize the expense of some of the interventions. So that's one thought about that. X might be optimizing the delivery of a product from factory to customer. Absolutely. And again, if there's big trouble, you can fix that. But, I've had a fair number of projects where we've looked at processes and we realized, wait a minute, there's no feedback loop here. It doesn't cause explosions, but if there were, people would come up with better solutions quicker, that kind of thing. Okay, I'm trying to figure out who's who. Let's see what else we got. Gerald Hermias, crossing interventions under the influence of elements within the organization that will work as obstacles or facilitators of success organization. Yes, it's true. You have to figure out how to work with those guys, and it often takes quite a while to have them be your friends and respect you. Oh, that's pretty interesting. Matt's comment about swim diagram, a maintenance column that can be helpful to avoid procedural drift. That's a really good idea. Another take on that, Matt, is that our colleagues at Amgen some years ago, and Gina Restor-Zadro, talked about ADDIE, which you probably know that acronym: analysis, design, development, implementation, and evaluation. And they added S for sustainment. And what they do, and you could certainly probably build that into a swim lane diagram, but what they do is they kind of have a contractual relationship with their stakeholders at the beginning of a project. And they said, okay, we're going to take our best shot at an intervention here, but we want to agree with you that we'll come back 8 weeks later or whatever after intervention, and we're going to do a quick and dirty 6 boxes analysis, because guaranteed we missed some stuff, and we'll figure out what those things are. And sometimes it's like blind spots, but they sort of built that in as a continuous improvement thing, which is another way to think about that in terms of procedural drift and stuff. But that's a good point. I see it. Looking at Hermias. This is great, by the way, guys. I really appreciate all these comments. Are there any elements we can address ahead of the intervention to help it succeed? Well, yes, Hermias, you can certainly educate them. I always like to get people, part of our sort of pitch, if you will, for performance thinking, and its plain Englishness, is it's not that hard for ordinary people to look at the models and the language. Depending, of course, in your case, you may be speaking to some people who are not English speakers. I don't know. But basically, the intention is this is pretty simple to understand. So even just explaining to people how we approach things will sometimes be an eye-opener. But we can also take into account the old guidelines from a lot of change management methodologies, like, well, try to identify some champions and some change agents who will help you make this thing happen, who will vocalize the messages, who will support and model the new thing, whatever it is. So sometimes you can find among your stakeholders, supporters and allies, maybe even in other departments, which would be ideal. And that's what I'm always trying to look for, but it takes time. You can't always get it instantly. Look at Erwin. The problem seen with the various improvement approaches is that when the leadership changes, yeah, no kidding. It's the flavor of the year thing. I experienced, so I don't know if you guys are looking at the chat box, but Erwin's comment is right on target. I spent 20 years trying to change American education system by introducing direct instruction and precision teaching, which we know produce dramatically superior results in kids' learning. And there were school systems who adopted it, but then they'd get a different superintendent. Sorry, we're going to do something else this time. So that's challenging. That's a common issue that we have. So I think our time is up here. Thank you so much for all your comments and everything. I'm really kind of super happy about this. I think if we counted them, we got more questions and comments than we've ever gotten. So you did great. Thank you. I think we're gonna finish now. As you all know, you'll get a link, or even if you don't get a link, by sometime probably on Friday, the recording of this will be there on YouTube. So thank you very much, everyone. Have a good one.